My goal here is to make an environment that people who are new to programming will be able to get in and explore something fun and exciting and different and creative that they can play with. I used to call this Pigeon Smalltalk. So if anyone's seen any previous presentations I've done, it was called Pigeon. I was told from some people who lived in France that pigeon was kind of a derogatory term in France. And pigeons were not very well liked. So I switched it to Beagle Smalltalk. The reason for Beagle Smalltalk, I haven't tried this yet. Next slide. The reason for Beagle Smalltalk was that the Beagle was the name of the ship that Charles Darwin used on his voyage of discovery. So since I'm on a voyage of discovery myself, I thought it was a good name. And besides, it gives me a nice little opportunity for an animated character to represent the small talk. A lot of my motivation comes from my early days in computing, so let me just go through a little bit what I went through back in the early days. 1977, I saw this article in Popular Electronics and thought, that looks so cool. I was already into digital electronics. I was building little digital circuits. I was 15 years old. And thought, I can build my own computer. So I bought all the parts, I put it all together, and ended up with this. Now, this is a later incarnation of my computer. This one was upgraded to 8 kilobytes. Yay! And you can see my, my storage unit here, my little cassette player. And back here, you can see a speaker. That was my audio device. It was controlled by one bit in the computer, so I could turn the speaker on or off. And it's amazing how much sound you can create, different variations in sound effects and music from just on-off. That computer was based on an 1802 processor. It was running at a stunning 1.7 megahertz. It had 8¼ of RAM and 64 by 64 graphics, black and white. And I was delighted. I thought this was so fun. And I did all sorts of stuff. I made little games that ran in the graphics. I did 1-bit sound and music. And once a friend of mine was into ham radio. So once I called him up and said, listen to this. And I flipped a switch and the computer went shh. And then I started typing on my keyboard. And it translated what I was typing into Morse code. So it would be and he was on the other end saying, I understood that. So those are the kinds of things I did. As I got more into computers, I started getting into more and more fun things. Question, has anybody here heard the term ray tracing? Yes. How many people have heard of a ray tracer, an open source ray tracer called POVray? Yes. How many people knew that POVray came from one called DKB Trace? How many people knew that I was the one who wrote DKB Trace? Thank you. POVray derived from work that I did on my Amiga computer back in the mid-'80s. I heard about ray tracing and I thought, that sounds so cool. So I decided to write my own ray tracer and I released it as DKB Trace. After a few years, it became pretty popular and people were asking me to add this and add that and change this and can you make this better? And I was getting lots of requests. And my problem was I was going back to university for a master's degree, and I didn't want to be bothered with all these requests for changes to this software. So there was a group on CompuServe, and I came to that group. They were talking about starting a whole new ray tracer from scratch. Now let's write a whole new one because Dave is not fast enough at putting these features in for us. And I said, tell you what we'll do. I will donate the source code for DKB trace to this group in CompuServe, and we together can develop it forward into something else. I have 3 conditions. 1, call it something other than DKB trace, because I don't want everyone to keep coming back to me for questions and comments and whatever. It's the group project. Let's give it a group name. So they came up with POV, meaning persistence of vision, is what POV stands for. Second was to keep it portable amongst multiple platforms. So at the time it ran on Unix, Amiga, IBM, Mac, and a few others. I said just keep it portable, which they've done. And the third one is what was the third one? Probably to keep it open source so that it was always free for people to use. And it developed into Pavre. That picture up top there with the ornaments was done with Pavre. If you're interested, look up pavre.org and you'll see all sorts of pictures that people do with this. They've developed it into quite a sophisticated ray tracer. So I can claim some credit to it, but most of the credit belongs to the Pavre team, and I haven't worked in it for years. But still, I came up with a program that did simulated physics for kids, so they could play with springs and elastics and gravity, and they had a way of scripting things with events and actions. When a particle hits a floor, then do this, play this sound. And it was pretty fun. So I released that as a commercial project. That never actually went very far, but it was still a fun project to work on. I was active for a while in virtual 3D worlds in something called Cybergate. And then I wrote other things. One day my son came to me and said, he was 13 years old, "Dad, you're into computers. Can you help me write a game?" "Sure, what would you like to do?" He says, "Oh, something like Halo." I said, "Oh, whoa. Turn your expectations down a lot here. Let's do something a whole lot simpler." So we ended up coming up with this. I'll show you a really quick demo of this just because it's fun. You see here, I will launch it here and pull it over to there. So this is my Space Wars game, and there are these ships that go by. Here, I'll make it full screen. There's ships that go by, and I can shoot at them. The sound is off right now, but there's we have some planets and stuff. So it was just a fun little game to play. Now I have to close this. Close. So I'll go back to my slideshow. Okay. This isn't projecting right now. Hold on. Okay, here we are. After that, I wanted to get into game development, and this is where it starts getting into Beagle Smalltalk. I wanted to be able to write games for Android and iOS devices. I looked around at the various Smalltalks, and all of them were JITted and couldn't really run on Android and iOS. This was several years ago. I realized that there was an experimental version of Pharo that ran in Android, but it wasn't ready yet. So I thought, I can do this. I can write my own virtual machine that's an interpreted VM that runs in Android and in iOS, and then run my game on that. And that's what I did. Again, I'll pull this over. Oops. There's that game running in Windows. I will play. It gives little instructions. Then I can do things like this. There are sound effects. They're turned off right now. So you have to line up these tiles from the highest number down to 1, and then the sea turtle will hatch and run down to the 1 and get washed away in the sea. So it was a puzzle game. So to do this, I ended up writing my own virtual machine. That VM only had generation scavenging. The old space was fixed, and that's just where all my classes and methods went. And all the dynamic data, that was all in new space, and it was just scavenged because there wasn't very much of it. And when you go from level to level, you clear out all your old objects anyway. So there was not a need at that time to have anything more than just scavenging. I have to learn how to resume my slideshow. So after that, I thought, now that I have this VM, what can I do with it? Well, I decided to go forward and write a compiler for the VM and actually create a whole Smalltalk that I can use for whatever projects I want. And that's what we have here. This is a Smalltalk that runs from a command line in Windows. The source code for the VM is tiny. It's the largest file of about 15 or 20 files is 49K. And the image now is getting bigger. It's about 5 megabytes. But the executable, the VM itself, is around 470K in size. So it's a pretty small Smalltalk. And let me give you a little demo of it rather than show it in slides. Hold on a sec here while it figures out what I'm doing. Okay. Okay, this is just getting weird. I'm going to kill PowerPoint. And we'll get back to PowerPoint. Hold on. Let me go to a different mode here. Stand by. Function that. I'm just going to to duplicate my screen, and that's a whole lot easier. Okay. This is Sigwin, where I'm developing it. I'll CD into my directory. Try that again. And I'll run my image. Now my Smalltalk image is running, and it's waiting for a WebSocket connection. So if I go over to a web browser and put in the URL, right now this is just a file URL, but in theory I could connect to it from over the internet. I've been able to get the VM to run on Windows, Mac, Linux, Power, or Raspberry Pi, and I've also been able to get it to run directly in WebAssembly in the browser itself. So I have a Smalltalk running in WebAssembly inside the browser. What I can do now is I can open up a browser, a system browser, and this allows me to navigate around and look at classes and look at methods and see what's in here. And I have a very simplistic syntax highlighting going on, but that uses the parser to determine the start and end of every selector and what kind of word it is, whether it's a variable or a message, and highlights accordingly. Then I have a workspace. Let me show you something. Okay, I'll switch to this microphone. String art window, open. The menu is a div with text in it with a click callback back to Smalltalk. So that's how that works. And here in the workspace, I'll just type self circle. I don't have to select it here. It draws a circle of pins. If I click on this button, Show Labels, it shows me the number of each pin. And my intent here is to give this to new programmers, new people who are interested in computers, let's say, and say, here, what if we say self move to pin 1, then self line to pin 20. Draw. It draws a line. And then let's have some more fun with it. Say self line to pin 30. Draw. And it adds into our diagram. And I think that's a very easy way for kids to be able to draw something on the screen. Once you have some code in here that does something interesting, you can put it into a method. Here's a method that draws an interesting picture. Let me draw the picture, and then you can look at the method and see if you can understand what it does. RGB mandala. Draw. Circle by default gives you a circle with 40 points. You can use circle colon if you want a different number of points. Set the color to red. From 1 to 40, move to the pin and line to the pin plus 9. The pin numbers are all modulo the number of pins, so if you go over 40, it goes back to 1. Change the color to blue and do the same thing, but add 19 to the pin. And then for green, add 15, and it makes this diagram. And this is the kind of thing I look at and say, oh, that looks so cool. And I did that, right? That's the kind of feeling I want to get out of this, is look what I did. Here's a fairly sophisticated one. This does a hexagon with double arches, meaning there's 2 levels. I'll show you when it comes up. It starts off going from 1 pin to the one at the next line of the hexagon, and it goes down that way. And then for a second pass, it goes to the line in the second line over. So it will go from here to there as the first one, there to there as the second, and so on. And it draws this nice little pattern. The colors are generated by HSV, so I can just say change the hue to a different hue from the last one, and it changes it to a slightly different hue, and you get this rainbow of color effect. So that's the sort of thing we can do there. I'm also interested in getting into 3D graphics. I'm the first to admit that this is cheating, but it shows that I can interface WebGL and do 3D graphics in this Smalltalk. So for right now, let me shut this down. I'll go back to my PowerPoint. ESUG. slideshow. I'll just skip through the other slides. Okay, so I showed you this. Some of the challenges I had doing this. Number one was doing brain surgery on yourself. Anytime you do something like this, you have to make changes that modify the tools that you're using to make those changes. And that's always challenging. At one point, I wanted to rearrange my bytecode set, but I had to do it from within Smalltalk because that's the easiest way to do it, because you have to change the image and the VM at about the same time. So I had a spare range of bytecodes that I wasn't using, so I recoded some bytecodes to use those spare sets. Then I went into Beagle Smalltalk and changed my compiler to use the new set instead of the old set. Then I deprecated the old bytecodes and changed them around, and then changed my compiler again. You have to figure out how not to paint yourself into a corner. The debugger was fun. I'll show that after. I have a debugger that actually lets you single step through, go into, over, and through. Through will jump into a block, so you can see what's going on in the block. Debugging the debugger is interesting because if the debugger doesn't work, it tries opening the debugger to show you that it doesn't work. And then changing the compiler itself is tricky. So you have to, well, quite often what I would do is make a whole copy of some code, edit the copy until the copy worked, and then copy it back to get it back to the original. Also challenging was garbage collection. There's a generation scavenger, but now there's a mark and sweep. And getting all that correct without losing objects and getting object pointers pointing in the wrong places and so on was challenging. My plan is to develop kits. Each kit is something you can load in and then play with. And I want to produce YouTube videos on topics like this to say, hey, let's do this project. Let's play around with ray tracing. I've done all the hard work for you. So I've built the ray tracer. Now let's add a sphere, add a light source, see what it looks like. Okay, let's make the sphere smaller. Let's add a second one. Let's put a floor in. And you can always incrementally see what's going on. And that can all be done through coding. I have an idea for puppet theater where puppets can come onto the screen, say things in a sort of a speech bubble, and then other characters can come in and say other things, so you can tell knock-knock jokes. Sound synthesis, music generation, digital logic to make counters and make flashing lights. Maybe an 1802 simulator, well, we'll see. And maybe simulated physics and some neural networks. So that's where I'm aiming for being able to produce kits for kids to use where I do the hard part underneath and you can play on the top. But I'm not going to stop you from diving down into any of the other code that I have and looking at it, understanding it, changing it, making improvements. Do whatever you want with it. It's your system. This is, I love Scratch. Scratch is a great environment, but I have 3 problems. 1, you can't see how Scratch is implemented from scratch. 2, it's hard to organize code in Scratch. It's just little pictures all over the place, and it's hard to find them. And 3, it's hard to debug Scratch. So I'm trying to address those 3 problems here and get an environment that people can jump into and learn to program slowly and easily, but have fun at it at the same time and learn the joy of programming. And that's what I wanted to present. Thank you very much. We have a few minutes for questions.
Simple question, is it available?
No. It's available on my laptop.
All right.
And not yet. If you really want to have it, ask me, and I could very well give you the source, but it's going to change. So I'm in the process of making many changes to it, and there are some areas that are still a bit unstable, so it's best, for me to fix those up first. But in a few years, it'll be available and open source.
Hello. The interpreter that you have is a bytecode interpreter, or
Yes.
So you have a bytecode set.
I have a bytecode set. The interpreter says, while one, switch over the next bytecode, and then a long switch statement, and then loop back. That's the heart of the virtual machine.
Thank you.
More questions?
Up there.
So you said your motivation was Scratch had the problem that's hard to debug. So how do you debug? So how is the debugger integrated in all these play toys? Does it pop up if a kid does something wrong, or how does it work?
I'll show you what I have now, if I can do it quickly enough. CD to my folder. Beagle. Junk class, new junk method. Select that, debug it. The bytecodes at the top are for me, so I know what's going on under the covers. That'll be removed in the final version. But there's the code that I'm executing, and I'm going to jump into the junk method, and then I'm going to do through. Factorial right now has 1. Hash has nil because we haven't assigned to it yet. Over. And so now hash has a number in it. And through, I'll do through a few times, and now factorial has this value in it. Does that look at all familiar?
Yeah, okay. The bytecode display is to teach the kids to also look at the bytecodes, to learn something about that.
Yes, and in fact, for my purposes, I can peek at the next bytecode and step by bytecodes. If I really need to, I have a way of stopping it and going into a more primitive debugger that's written in C, and everything is, like the whole Smalltalk image is static, so I can actually look at memory addresses and see what's going on. But that's just for me. I don't expect kids to use that. Other questions? Down here.
It is the UI also written in Smalltalk, or
Yes.
you're just doing some JavaScript there?
It's written in Smalltalk, outputs JavaScript. So it will say things like, go find the document dot get
Yeah, the DOM thing.
by ID, blah, blah, blah. Set the inner HTML to this. And then we'll provide HTML, and then JavaScript runs that and replaces the HTML, and it does the display. But when you click on something, it calls back into Smalltalk. Smalltalk processes that and then tells JavaScript what to render. Happy to demo any details of this to anyone who's curious.
Thank you.
Thank you very much.